Hello everyone. In this video, I will continue talking about concrete mix design. I will talk about how to determine the suitable coarse aggregates you are going to use for the project. There are several general guidelines. First, you need to use largest practical maximum aggregate size and most dense gradation for the most economical mix. Large aggregates minimize the amount of water required and therefore they reduce the amount of cement required. Round aggregates require less water than angular aggregates for an equal workability. And in general, smooth texture requires less water than rough texture for an equal workability. Let's see how to calculate the maximum aggregate size you're going to use for the project. So based on this table, you can see maximum aggregate size is limited by the dimensions of the structure. And maximum aggregate size should not be more than 1/5 of minimum form dimension, and it should not be more than 3/4 of minimum clear space between reinforcement or pre-stressing tendons, which is denoted as S in this figure. And it should not exceed 3/4 of minimum clear space between reinforcement and form, which is denoted as C in this figure. And it should not be more than 1/3 of the thickness of unreinforced slab. And please note that this is the only place in the mix design process where we use maximum aggregate size. In the following process, we will always use nominal maximum aggregate size, which is generally 1/5 size smaller than maximum aggregate size. Let's see an example about how to calculate maximum aggregate size. So we will build a structure with concrete with a minimum dimension of 0.2 meter, and minimum space between rebars is 40 millimeter, and minimum cover over rebars is 40 millimeter. Two types of aggregates are locally available with maximum sizes of 19 and 25 millimeter respectively. If both of them have essentially the same cost, which one will be more suitable for the project? Okay, so let's see how to calculate the maximum aggregate size. So first, as shown in this table, they should not be more than 1/5 of minimum form dimension. The minimum dimension here is 0.2 meter, which is 200 millimeter. So 1/5 of 200 millimeter should be 40 millimeter. So you can see both 19 and 25 is smaller than this 40 millimeter. So both of them satisfy this requirement, right? And the next one, they should not exceed 3/4 of minimum clear space between reinforcement or pre-stressing tendons, so which is 40 millimeter. So 3/4 of 40 millimeter will be 30 millimeter. So you can see both 19 and 25 satisfy this requirement. The next one is it should not be more than 3/4 of minimum clear space between reinforcement and form, so which is the minimum cover over rebar, so which is 3/4 times 40 millimeter equal to 30 millimeter. Again, both of them satisfy this requirement as well. Okay, so we can use, so actually both of them satisfy the dimension requirements, but according to the general guideline, large aggregates can be more economical because they require less water and less amount of cement. So we need to choose 20 millimeter as the maximum aggregate size. Okay, so then let's see how to determine the mass of coarse aggregates you're going to use for the project. So in the previous step, we know how to calculate the maximum aggregate size, and the nominal maximum aggregate size is usually one sieve size smaller than maximum aggregate size. So after you know the nominal maximum aggregate size, and also if you know the fineness modulus of the fine aggregates you are going to use for the project, then based on this table, you can find the volume of coarse aggregate per unit volume of concrete. So let me show you an example. If the nominal maximum aggregate size is 19 millimeter and the fineness modulus of fine aggregates is 2.7, then based on this table, you can find the volume of coarse aggregates per unit volume of concrete, which is 0.63. Okay, so if we know that the dry rounded unit weight of the coarse aggregate is 120 pounds per cubic foot, then you can multiply 0.63 by the dry rounded unit weight of the coarse aggregate to determine the mass of the coarse aggregate. So basically the mass of coarse aggregate will be the unit weight, which is 120 times the value we got from the table, 0.63. This should be equal to 75.6 pound per cubic foot. And if you convert it to per cubic yard, then it's 2041. So this is the mass of coarse aggregate per cubic yard of concrete. The volume of coarse aggregate can be increased by 10% when less workability is required. For example, in pavement construction, and you can also decrease the volume of coarse aggregate by about 10% to increase workability. For example, if you want to do the placement by pumping, then you need to increase the slump. So you can decrease the coarse aggregate volume by about 10%.